Right, hi everybody. Look, reasonable thing. The sun is out, so it's shining in through my window, and the quality's not too bad on the rubbish laptop camera. Right, now, as we can see, it says how to measure DC amps. You've bought a power supply for a said job, and you want to know how to measure it says 12 volts 2 amp. You want to know how to see if that is correct, because under load it should remain at 12 volts, and you want to find out if it does remain at 12 volts under load, because that's what you need to run the piece of equipment that you're going to run. Now you will need a CHEEP multimeter, and the first thing I always do is grab a Sharpie and mark the little arrow. Then that way you know for a fact where you're switching it to, because it's not very well marked. That's the only thing I do. Okay, the black wire is your common or negative or minus. So common, negative, minus. The red wire is your positive or plus. Doesn't get a third name, but I'm plugged in at the moment in the volts, ohms and milliamps. Now they are for low currents. Well, this says 2 amps. Show you a picture close up of that. As I say, 2 amps. So we're going to need the 10 amp range on this cheapy £2 multimeter. Now, when you plug into the 10 amp range, never ever take these cheap rubbish leads and put them in the mains, because they explode. The leads actually burn out and melt. Go and watch Diodes Gone Wild for a demonstration of these burning out. Never ever use these in the mains, they're rubbish. Okay, oh, knocking the resistor everywhere. Now, to measure the output current of that, you'll need a load resistor. This one is a 7R5 ohm, so it's 7.5 ohms at 5 watts, and I'll show you a picture of that. So you can have a look, and that is good enough for low voltages, 2 amps. We'll do the maths now. This is the Ohm's law table. You can pause the video to study it or take a screen grab. Right, so we know our power supply is 12 volt at 2 amp. Right, so we know it's 12 volt at 2 amp. The resistor, 7.5 ohms. Remember our Ohm's law. Oh, move. V-I-R. So volts divided by the resistance will give us our current. 12 volts divided by 7.5 ohms, 1.6. That's 1.6 amps. So that's 12 divided by 7.5 ohm, 7.5 R, 7.5 ohms. That's equals there, so equals 1.6. So that's AMPS. Okay, so that's what it should draw. And this 2 amp power supply should be quite happy. There should be no voltage drop. And that's what we do next. Right, volts and amps. The putting out 12 volts. This lead is coming from the current meter, and I connect this to ground. I'm going to connect this to the ground. You can't quite see that. I don't want to get that resistor too close to there. That's the plug that's on the thing, the 2.1mm plug. And basically I connect it to ground, and as you can see, got 155 and 11.96 volts, and that's quite good enough. That means the power supply can deliver without failing, but the resistor does get a bit warm, very warm. Very warm for that short period. So obviously I need a larger wattage resistor. That's only a 5 watt resistor, so I'm dissipating more than 5 watts. So we now do the maths to work out exactly what we're doing. Volts times current equals watts. So there you go. 12 volts times 2 amps is 12 twos are 24, so 24 watts. The dropped amps we had was 11.96 volts across 1.55 amps, gives us 18.52 watts. So we really and well and truly overdrove the little 5 watt resistor. There you go. So it should have been at least an 18 to 20 watt resistor. The circuit is, I'll use this as the pointer. This is a piece of wire going for the center positive, coming out to the positive of the voltmeter, coming through the resistor to the negative of amp meter, this. The next one along is empty. Now that was the positive from the center of the thing, coming to the red probe for there, linked with this red black wire. The red wire is coming from the negative of the power supply to the negative of the voltmeter, and that is how it works. So the resistor's in line with the negative of the current meter, but it's directly connected via this wire, this red wire, to the negative of theirs. So that's parallel connected, and this is series connected. And when I put this probe on the negative of the input, we create the current load. As you can see, 1.5 amps and down to 11.96 volts. So I'm not going to keep it on there too long because that little resistor gets too hot, but it shows that the power supply does what it says on the box, or it's thereabouts. So it is a 1.6 amp power supply, really, 1.5 amp, and that's more than what I need for it to do for its job that I'm going to do it.